Okay, so in question 8, we have that the light bulb shown below is able to operate either with direct current or alternating current. It displays the optimum operating conditions, and the accompanying graph displays the current type that is being used. So currently we have this graph here is the current potential difference that it is experiencing. Okay, so first question, is the bulb operating with direct current or alternating current? Well, as this student says, this is alternating current. Alternating meaning it changes direction, and we can see that the voltage is initially negative, then positive, negative, positive. Direct current would also have these peaks and troughs, but instead of peaking at a negative and then positive, it would always be on the positive side. Okay, explain the 100 watts. Okay, so what does 100 watts mean? The student says 100 watts is the maximum power that the globe can take for it to glow. This amount makes it glow at its brightest, which is the most work done. Yes, that is definitely true. You could say it that way. Let's see what student 1 said. Actually, I've got him open on here. There we go. He also said it's alternating current. The bulb converts, yeah, that's what the word I'm looking for, converts 100 joules of energy per second to light. That's very important. You can't see that on here, but that's the exact answer. Is that I do think you might get your full marks for the previous one, but the actual answer is that it converts 100 joules of energy per second to light, and not just light, but also to heat. Especially these halogen or gas type lamps get very hot, so a lot of energy is dissipated in heat. So yes. Okay, let's see, next question. Calculate the RMS current in the bulb when it's connected in a circuit. So the RMS current is reliant on, in order to get the current, we first need to get the and at this stage, what do we have? We only have power and we have voltage, and so we have the average power. So that is as well. Let me just see, optimal operating condition. Yeah, this 100 watts is the average power. So just before, the other student said, or this student said, the maximum power. It's not the maximum power, it's the average power. Okay, so then in order to calculate the current, I can use my formulas, and let's just look there where I have, find it down here. Here we go. So I can use in this expression, I can use my average power, my RMS voltage, to get my RMS current. Okay, and so what we first have to do, and again, let me just move this up a little bit, then you can see. So we'll first have to work out the root mean square. That's what RMS voltage, because that's the only information we have, is the maximum volts. So maximum volts divided by the square root of 2 gives me the root mean square voltage. And then in here, I can just divide both sides with the root mean square voltage, and that will give me the root mean square current. So average power, which is 100, divided by the root mean square voltage, gives me then this answer, and that is absolutely perfect. See what the other student did. Answers in here. Okay. Yeah, well, he gets the same thing. He just substitutes instead of substituting by calculating this separately. He's just doing it in the equation. So he's just replacing root mean square voltage with the formula in the equation, and that's perfect. That's very well done. Okay, let's see what the next question's asking us. Explain why ESCOM prefers AC instead of DC for long distance transmission of electricity. See what the student says. AC does not need much current to keep traveling distances, but with DC you will need more current to travel longer distances, so it means bigger cables, more copper. So it is cheaper to do AC than DC. Also saves because current kills. Cheaper to do AC. Also saver because copper kills volts. It is definitely cheaper to, and I think the reason is correct as well, that the current, and I think the best way to explain it is maybe just to read from this is the CAPS document. So this is the answer that all markers in an exam should first consider, and this is what it says. The main advantage to AC is that the voltage can be changed using transformers. Okay, so the voltage can be changed using transformers. That a transformer is a device that's used to increase or decrease the amplitude of an AC input. Okay, so we've got an AC coming in. Where's my question paper now? There. We've got AC coming in, and this is the, as they say here, the amplitude, the height. Okay, this height can be changed using a transformer. It can be stepped up or be stepped down. So at power stations, so that means that the voltage can be stepped up at power stations to a very high voltage, so that the electrical energy can be transmitted along power lines at a low current. So that's what the student and the other student was saying as well, is to decrease the current by increasing the voltage at a low current, and therefore experience low energy loss. And so as we can see here, that my current is invertedly related to my voltage. So if I increase this, I'm decreasing my current and decreasing the power, the energy loss due to heating in the cables. So that's definitely the main reason. And then also can be along the power low current, therefore experience low energy loss. The voltage can then be stepped down for use in buildings, street lights, and so forth. Okay, so that's the main advantage, is that and as well as they correctly identified, is that it can be transferred at high voltages. It's easy to step up or step down, and because it can then be transferred at high voltages, it can run at a lower current, which makes the loss of power or energy rather less due to heating in the power lines. Okay, there's some other advantages as well. For example, there are more damages to DC currents during the conversion process. There's damage to the transmission material, but I think if you get this one will be the one that is assessed and that is asked in the exams.